Ernest Rutherford? That's his life from August 30, 1871 to October 19, 1937.
Rutherfordium is the
Whoops, wrong voice. Let's try again. Rutherfordium is the 104th element, and transition metal with 104 protons and 104 electrons with 157 neutrons. Rutherfordium was discovered in 1969 by Albert Guyot, Matti Nurmia, James Andrew Harris, Kari Iskola, and Pirkko Iskola with a density of around 23 grams per centimeters cubed. Rutherfordium has a melting point of 2400 degrees Kelvin and a boiling point of 5800 degrees Kelvin with an atomic weight of 261 atomic mass units, and it was named after the New Zealand-born British chemist and physicist who won the 1908 Nobel Prize in Chemistry, Ernest Rutherford. It is classified as metallic due to its position in the D block on the periodic table, but its appearance is unknown. Rutherfordium was discovered by a team of researchers working at the Nuclear Institute in Dubna, Soviet Union. Although the Dubna team claimed discovery in 1964, an independent team at Berkeley also claimed discovery in 1969. Despite the dispute over who is responsible for the discovery, the IPAC gave credit to the Berkeley team and therefore designated their name for the element. As a synthetic element, rutherfordium can be synthesized in a lab, but is not naturally occurring on Earth. Therefore, there are no known commercial uses for rutherfordium, as it cannot be mined and its sample sizes are so small. There are no stable or naturally occurring isotope of rutherfordium, although several radioactive isotopes have been created. The synthesis of these radioactive isotopes occurs from the fusing of two atoms or by decay of other elements. 15 radioactive isotopes have been isolated. Rutherfordium has a number of chemical properties similar to those of hafnium. It is in the 6D series for the transition metals, and is the first of the transactinide elements. If enough of a sample had been synthesized to accurately observe it, rutherfordium is expected to be a solid under normal conditions. Rutherfordium is believed to have a very stable, high melting point oxide state. In their attempts to reprove their claims on the discovery of the element, the Dubna team isolated the gaseous phase of rutherfordium. More recent experiments on the gaseous and aqueous phases have been more conclusive. Stay tuned for dubnium.